These are the fundamental particles in nature. We have the quarks. Some of these quarks make up the nucleus of the atom. These are the leptons, of which electron is one. Neutrinos are others. Then we have the force-carrying particles, photons, gluons, and bosons. Then we have the Higgs boson. The Higgs boson is what gives particles their mass. Now all of these, they have antiparticles, with the exception of the photon. Photon does not have an antiparticle. This is what's in the nuclei of the atoms, protons and neutrons. But protons and neutrons are not fundamental particles. They're not elementary. Inside they have 2 up, 1 down quark for the proton, 2 down and 1 up quark for the neutron, and the electron orbits the nuclei. Here we have a proton that makes up the nucleus of the atom, and then around it we have places where the electrons can orbit the proton. These orbits are called ground state, that's the first state, second, third, fourth, fifth state. We can also call them orbitals, we can also call them levels. There's a lot of different names we can call these things. Now the electrons can exist in any one of these orbits, but they cannot exist in between the orbits, and that's one of the properties of quantum physics. Quanta is a certain amount of energy, it's a minimum amount of energy that is required for the electron. And so here, the electron has a certain amount of energy in the ground state. When it goes to the second state, there's also a certain amount of energy it's required to have. In between the states, it's not allowed for the electron to exist. Now here we have an electron orbiting the proton. Inside the proton we can see there are quarks that are moving around, and they're held together by this strong nuclear force. It's the gluons that are keeping the quarks in the nuclei of the atom. There's 3 of them here. There's 2 up quarks and 1 down quark. Now this is one way to represent the atom so we can understand it, but in reality most likely atoms look something like this. The orbits are not as nice and round as we see in the Bohr atom, and so what we have are waves basically. So electrons act like waves. When you observe them, then they act like particles.